Hey guys, let's do it. This is our most important assignment yet, this grading period. We got to get this homework done so we're ready for the test. So let's take a look. It says, what relationships exist between sides and angles that can be used to prove congruent triangles? So if you actually look through here, I think it actually sums this up in the last section. So here it is. On the last page, it says that the congruence criteria is, all congruence criteria is that if the angle of these, or the order of the angles in the sides are in these patterns, then the two triangles are congruent. So that's essentially what we're looking for. And so those are the relationships. So the relationships between sides and angles when pairs of sides and angles are present in these specific orders. So when our evidence spells side, 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 angle, side, angle, side, angle, 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 side, or HL, then there is a relationship present and they are congruent, right? That's basically what this whole chapter is about. Now, there's some other things in this chapter that we'll get to, too, that fit nicely into these context of the chapter. So let's take a look. It says, figures that have the same size and the same shape, okay? Those would be congruent. So we did a foldable today, and that foldable talked about congruent and the same words, right? Sides of an isosceles triangle that are opposite the vertex. So if this is the vertex, so the side of an isosceles triangle that's opposite the vertex. Okay, so that would be called my base, the side that's opposite my vertex, okay? Rigid motion is sometimes called, okay, this came right out of our notes, right? Sometimes called congruence transformation, right? And then the last one, the legs of an isosceles triangle, so these are the legs. The legs of an isosceles triangle form an angle called the vertex. That's the vertex angle. Okay. And these were on our foldable, so pretty interesting. All right, now let's review 4.1. It was this basic idea of congruence. So this kind of comes up the whole chapter. So it says two figures are congruent if rigid motion or a sequence of rigid motions would map one object on top of the other. So we're noticing here with this like kind of a Pac-Man shape that if I translated this right a certain amount, it would land right on top of this one. And so that could be proof that yes, by translation, they are congruent. So that would mean this is a congruence transformation. That's the definition of that word. So looking at our questions here, it states, for these exercise questions 6 and 7, determine if figure A is congruent to figure B. And so I notice if I reflect this over the vertical line, so we could call that a vertical line, or you could call it a y-axis. It maps upon itself. So we're going to say yes, congruent. What about this one? This one is not. No, because it has to map on top of it. So if I put A on top of B, it would cover B up. It doesn't line up. So no, because A is bigger than B. It's got to be the same size and the same shape. Couple different reasons why you could explain. All right, last question, number 8 on this section is if a figure is reflected across the same line twice. Okay, so let's just take a figure. It doesn't matter what it is, I guess this triangle. If I flip it over this line, all right, so this is figure 1 and this is figure 2. I flip it over that line. And then let's say I flip it over that line a second time. So now I'm back over here. So my purple one is my third triangle. Is the resulting image congruent to that figure? And the answer would be absolutely yes. It maps right on top. How do we know? It maps itself right on top. Cool. Okay, so lesson 4.1 we reviewed. So what happened in lesson 4.2? These are the isosceles and equilateral triangles. So remember that the vertex, we called this one up here the vertex, and these down here are the base angles. So why is it so important to identify these things? Well, the reason is because the base angles are congruent. If these two sides are equal, then the base angles are congruent. So that would mean that if A is 75 and they're equal to each other, then angle C would be 75. So using this knowledge, if I look at question number 9, if these are equal, then this would make this my base, correct? And so then that would make these my base angles. So if that base angle is 45, then this base angle is 45. Now it says in the question, find the unknown angle measurements for each triangle. So they want me to find all the angle measurements, so angle I, angle G, and angle H. So we know H is 45 and I is 45, and we know, I don't know what this one is, so I could call it X. We know they all have to add up to 108, so I can add those up. Okay, so kind of doing a little bit of algebra here, we notice that X ends up being 90. Okay, so that's angle G is 90. So here's the measurements of all the angles. Now looking at question number 10, I identify that these sides are equal, therefore these angles would be equal because this has to be my base. So I'm just going to twist my paper a little bit, which means these are my base angles. Make sense? Okay, so I don't know what those are. I'm just going to call them Y because I don't know what they are, right? I already used the letter X for that other one. So, okay, so we got 40 plus Y plus another Y. All those angles have to add up to 180, right? So I've got 40 plus 2Y is 180. Now doing a little bit of algebra. I got one more step to be done. Y is 70. But that's not answering the question really. So I have three angles here. Angle L, which is Y, so that one's 70. Angle M, which is Y, so that one's 70. And angle N, they told us was 40. So if we want to just double check, make sure all those add up to 180. So let's take a look at question number 11. It says a zipper bisects the vertex. So if this cuts this in half, that makes this angle and this angle equal to each other. And so we actually notice that the triangle on the left, if I think of this as different triangles, this one is congruent to this one because of side angle side. But we haven't gotten to that yet. So what is it asking? It says a zipper bisects the vertex of the front of the tent, which is in the shape of an equilateral triangle. Ooh, so we said equilateral triangles, in our foldable, equilateral triangles have equal sides and equal angles. All the angles are equal to 90. All the angles have to be equal to, 60. 60, 60, 60. So all those angles are equal to 60. So it says, what are the angles measures of the resulting triangles? So this would be 30 and 30, right? Because when I cut 60 in half, this is 60, this is 60. And notice these would be 90 degrees. So the angle at the top is 30 each, right? The angle out to the sides or my base angles are 60 each. And then in the center of my tent, both of those are 90 degrees each. Nice work, guys. All right, so reviewing for 3, it says prove and apply that side angle side and side 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 are congruent. So as we look at here, this would mean that the angle is included, right? The A is in between the two S's. And this would be SSS is our 3 sides. And of course, we know that once we prove the 2 triangles are congruent, then the rest of the parts have to be congruent as well. So looking at the example, we have a side and a side. A second side matches a second side. And don't forget these vertical angles. So that's vertical angles means this evidence spells side, angle, side, side, angle, side. So this is congruent because of side, angle, side. Using this as an example, let's take a look at some more practice questions. We see this triangle has one side that matches one side, a second side that matches a second side, and notice this third side, because of reflexive, is congruent. Okay, so we can say which pairs of triangles are congruent. We can say, yes, these are congruent because of side, side, side. Notice we have a side, and a side, a purple side, a red side, and a brown side. So, yes, side, side, side triangle congruence. And we can name this. Okay, so we got A, B, D is congruent too. So I went across the purple and then across the third side. Across the purple and the brown side. So across the purple and the brown side. All right, now what about this one? So it looks like this is what ass spells like. So I have to say not enough information. Right? Because I have a side and a side, a side and a side, and this angle is not included. So that won't work. That's not enough info. Now looking at 14, it says the paths of a ping pong during a 2 separate serve intersect at the center of the table. How many pairs of congruent triangles can you find? So here's a triangle, right? And it's congruent to this triangle, right? And aren't all these triangles exactly the same size? I don't know if you noticed, but there's this triangle, right? And that matches this one. And we have this triangle, which matches this one, right? And we have this triangle, which matches this one. And this one. Right, so this one, and this one, and this one, right? So when they say how many pairs can I find, it's lots. I think I rattled off at least 10. I'm not sure how many pairs, a lot. Check out the next video for the second section.